Assalamu alaikum, students. Now, this is video number 3, which I'm recording for explaining you the concept of momentum, which is in the study list for end of term final exams. As in front of you, the screen which is shared, chapter number 9 is on momentum. A squash ball of mass 20 grams is given a speed of 16 meter per second. Calculate the momentum of the squash ball. So, guys, as you know, as per SIU system units, the grams should be converted into kilograms. So then my mass is will be equals to 0.02 kgs, and then momentum is equals to mv, so 0.02 times 16, and the final answer comes to me is 0.32 kg meters per second. That's the first question. Next is a frog of mass 20 grams. Again, you need to convert the mass into kilograms, so 0.028 kgs. The speed is also given to us. And what is the initial momentum? So momentum is mv, and 0.028 times 8. And once you multiply them, you will be getting 0.224 kg meters per second. And then after that, a lorry of mass 6 tons, 6,000 kgs is the mass. Speed reduces from 15 to 8. We want to find the change in momentum. The change in momentum is mv minus mu or mv minus u. This is up to you to find it. So final velocity, mass is given to you 6,000. Our v is 8. Our u is 15. When you subtract them, you get negative 4.2 into 10 raised to the power 4 kg meters per second. My momentum negative, it means that momentum will be decreasing. Okay, momentum is a vector quantity, positive and negative. If you get a negative momentum, it means momentum is decreasing. Now we go to the collisions, in which we will apply the law of conservation of momentum. Before the collision is always equal to the law of conservation of momentum after the total momentum before the collision, and total momentum after the collision. That is always equal to each other. So two particles of mass 0.2 kg and 0.5 kg are at rest on a smooth horizontal table. P is projected towards P with a speed of 2 meters per second. Find the momentum of P. So momentum of P is very easy, which is mv. And I can say 0.2 times the speed is 2 meters per second. So 0.4 kg meter per second. That is the momentum of P. We found it. Then after that, he said, like after the collision, P continues to move in the same direction with the speed of 0.3. Find the speed of Q after the collision. Now we need to know what was our initial momentum. Initial momentum mass of P was 0.2. It was moving with the speed of 2. Q was in the position of rest, having a mass 0.5. So it was in the rest position, so 0. After the collision, 0.02 is the mass of P, and it moves with the velocity of 0.3 in the same direction. That's why I wrote positive velocity. Plus 0.5 is the mass and of Q. We want to find the velocity. So when you use equation solver, you will get velocity of Q equals to 0.68 meters per second. Question number 2, if you can look at that, two bodies A and B of masses 4 kg and m kg are traveling in the same direction in the same straight line. A is traveling with a speed of 5 meters per second and B is traveling at a speed of 3 meters per second before the collision. So we need to know what is the total momentum before the collision and what is the momentum after the collision. So before the collision, 4 times 5 plus the mass of B is not given. I write M. And what is the speed it has? 3. Okay. And it is equals to, after the collision, the body A, which has a mass 4 kgs, moves with the speed of 2 plus um, the second particle, which has a mass m, I'm talking about particle B, it is moving with a speed of 4. When we solve this equation, we get m is equals to 12 kgs. Now we go to the question number 3. Now, question number 3 says that two particles A and B of masses 2 kg and 5 kg respectively immediately before the collision, and A has a speed 6 meter per second and B has a speed 3 meter per second in a same straight line, and they collide and coalesce. So coalesce situation is that situation that when they collide with each other, they become one solid and their masses has to be added. That's the coalesce situation. Otherwise, there is no any other new situation happen in the question. So find the speed of the combined particle immediately after the collision if they are initially traveling in the same direction. If initially they are traveling in the same direction, what is the law of conservation of momentum tells you guys? So 2 times 6 mass times speed plus 5 times 3. I'm talking about the momentum of particle B, which is equals to, can I add the masses now? 2 plus 5, and I want to know what would be the speed. So this will give us V is equals to 3.86 meters per second, 3 significant figures. Now he says that if they are moving in opposite directions, excellent. So 2 times 6 plus 5, instead of 3, I'm writing here negative 3. And then we will write 2 plus 5 times V. So in such a case, V will become equals to 3 over 7 meter per second. Now come to the question number 4. In the question number 4, we have masses 0.2 and 0.3 are free to move in a horizontal line on a smooth horizontal table. P is projected towards Q with a speed of 0.5. At the same instant, Q is projected towards Q with a speed of 1 meter per second. Q comes to rest in the resulting collision. Find the speed of P after the collision. So what are we going to do? We are going to apply the law of conservation of momentum, which is 0.2 times 0.5 plus 0.3. It was moving in the opposite direction, right? So P is projected towards Q with 0.5 at the same. Q is projected towards P. So speed is the direction is different, opposite. So I'm going to write -1 is equals to 0.2. I want to find the velocity of P plus the second particle comes in the position of rest, 0. Clear? So the VP will come to me is equal to -1 meters per second. Since the examiner is asking you speed, speed cannot be negative. So speed of P after the collision will be 1 meter per second. Don't write the negative sign with it. And that's all, guys. Our review pack is finished. I hope, inshallah, tomorrow you will perform very good. And you have to go through with the review pack very well. If any question again appears and in which you are not very much cleared, Newton laws are important, friction, and the third thing is momentum. And in this way, you can prepare well for the final exam. Thank you, guys. Assalamu alaikum wa rahmatullahi wa barakatuh.